Anyway, looks cool, dude. You got shocked by electricity.
Yeah.
Funny. That's funny. So I got your work here. Now I assume you've seen scientific notation before. Yeah, let's get to it. It's okay. I hope
Yeah.
you've had your good day at school. Yeah,
Yeah.
right. Okay, good. Now I want to recap a little bit for scientific notation. The the form looks like this. Let me stretch it out more here. Oops. I'm sure you're familiar, but you have a lot more to do than just this. This is still early, dude. You see how you have more like adding, multiplying, dividing. It's coming up right away. So you have to be
Yeah.
really comfortable at getting or changing it into scientific notation. So let me recap, okay? It looks like this. The form scientific notation looks like this. You can have you have to have one digit in front of the decimal only, and you can have as many as you want behind it times 10 to what some power. Okay, remember this.
Yeah.
You got to have only one digit in front of the decimal, and as many as you want behind here. Now, your teacher may be teaching you this a little different with the word left and right. Left and right, like move the decimal left and right and all this, and the exponent is that. I don't know how your teacher would do it. They do it one way or another. So I'm gonna go one way that is actually the easiest and easiest to remember how to get the answer. So your teacher may say it kind of opposite, but the same answer. Kind of opposite, but the same answer. You'll see what I mean. But I hope that he or she will do the exact same thing as I do, because when you move on, you will see it the way I see it. Therefore, the way that you some teacher would teach it, it's kind of confusing, and you may not like it later on. And you're like, "What was that again?" It's like, wait, do I do I move this way, move that way? Is it add exponent, subtract exponent? You'll see what I mean by adding and subtracting exponent when you have to actually combine scientific notation and all that. It's like you got to be pretty much on top of it real fast. But let me try it and see. Hopefully your teacher will say the same way. So anyway, you already started it, and they're good. I can tell. But let me check. Yeah, 6-4. Yeah, looks good. Okay, like number 3. Let me try it. Like pretend I'm teaching you it. Okay, so it's go like this. It's gonna go like this. Number 3. And I know you know it, but the way I would describe it, because this way may be kind of important later on when we do something more complicated. So here we go. So I would do 7.45. You don't need the 0 times 10 you, to the third power. You don't need to write the 0, but you have to account for the 0 like this, right? You see that? Okay.
Yeah.
Now, okay, right now, it's not much of saying left or right decimal or anything, but I think number 4 is going to happen right here. So here we go. Number 4. I know that you're going to, put the decimal in right there, right? Between the 3 and the 7. So let's do that. You're going to do a decimal between 3 and 7 like this, okay? But you okay? Like look at the original number times 10 right here. When your teacher may say this differently, watch me saying it, okay? Now kind of follow me the best you can here. It's not a big deal, but the thing is that I think it will be kind of handy later on. Okay, now here we go. I'm going to fill in the exponent. Now the way I talk is this way. The original decimal is right over here, right? It's over here, like the original decimal. But you made the decimal to be between. Oops. You made it new. You made a decimal to be between 3 and 7. Now, how do you get the exponent? If you move it to the left to the original, how many times? If you move it to the left to the original to get to the original decimal, that is going to be the negative. If you move it to the left to get to the original, it's negative. So
Yeah.
how many places? Let me see. 1, 2, 3, 4, 5. So -5. So your teacher may say something opposite right here, but as long as the answer is the same, you're good. You can eye it however you want. Okay. So
Yeah.
I'm gonna talk this way always, because you'll see how much nicer when you combine things like multiply exponents, divide exponents, and fixed exponents. You'll see. Yeah, I hope. Yeah, I hope this is going to be pretty handy later on. Okay, number 5. Okay, so you know you're going to put the 5. Now, you don't need to put 0.00 or anything, just 5. But imagine it's right behind. You don't have to put the decimal either. It's just 5. But times 10. See, the decimal is right here. I'm moving it back 2 places. That's why it's negative 2. Back 2 places to the left. That's why it's negative 2. Okay, number 6. Okay, so this one. You need to account for this 7 at least right there, or the 07. So you have to, number 6, sorry. So you have to maybe stop right there. So anyway, 6.704. You have to account for that decimal, that digit, sorry, that 4 digit. Okay, so okay, here we go. Watch. This time it's going to be the way I said it, the other way around. Here we go. The original decimal is right back here. You don't see one. It's right behind the 0, right? It's right
Yeah.
back right there. You don't see one. But since you made it between the 6 and the 7, right here, you move it to the right. Watch, this is why it makes perfect sense. Your teacher may say this opposite, dude. You move it, but the answer is the same. You move it to the right. 1, 2, 3, 4, 5, to the original decimal position. It's positive, but times 10 to the positive 5. That's why I worry that you might get confused when your teacher talking. The answer is the same. The exponent is the same. The negative, positive, whatever. But you get it? You see how I talk it? So yeah, you
Yeah.
made an original decimal position, but you move it wherever. If you move it to the right to get where the original was, therefore, it's positive 5. But your teacher may say it different because you move the decimal back here to the left. It's negative. Well, you don't say she won't say negative exponent 5, but she'll say something about move it to the left where the original is. That's why opposite being positive 5. I don't like that. You see, that's
Yeah.
why it makes more sense the way I talk it, the way I say it, or the way I explain it. So think about it, okay? But the answer is the same as long as you know it. Yeah, I think you know what I'm talking about. Your teacher may say, hey, the original say, but you move it to the left, therefore the exponent is positive. It makes no sense. That's why this way it talks that the way I talk is more to the point where it makes more sense. I guess it sounds better with the position of moving it, and that's the sign. So I think you understand. Yeah, as long as you get the right answer. So here we go again. I'm doing it the same. The decimal is way back here. The new decimal place you made is right here between 7 and 0. We keep that 7 back there. And you're moving it to the right, to the original. That's why it's positive. Makes perfect sense, dude. Let me see. How many places? What is that? 9? By looking at the
Yeah.
commas, right? 9. Yeah. So it's
Mhm.
positive 9. I'm moving it back to the original. 9. There it is. Don't worry. As long as you get the right answer. 8. Oh yeah, put it in the, sorry, I should be putting in here, right? Sorry. So it'll be 8.9 times 10. Now I'm moving it from here to the original, to the left. That's why it's negative, dude. What are you just saying, dude? Opposite, but it's the same answer. You're going to the right, right? The teacher will be saying, oh, you're going to the right where it is. So that's why it's opposite here. That's confusing, dude. Think about it, okay? But okay, as long as you get it right. So anyway, I'm moving it back to the left, to the original, okay? 2, 3, 4, 5, 6, 7. Is it negative 7, right? I
Yeah.
think. Yeah. Okay, now what about this one? Wow, look how fancy this one is. It'd be 1.8 and all of that behind it, dude. Your teacher didn't say, round it to decimal places. Now, in chemistry, your teacher may ask you to round it to, like to certain decimal places. I forgot the term in chemistry. You'll see. So you can kind of omit some of this back here if your teacher asks you to do it. But right now, you're going to keep all of that. Okay, now the original is right here. You made it here. Now you can move back here. To move back to the original is negative. That's why it's -1. There it is. Simple as that. Move it to the left. To get to the original, it's negative. Okay, and this one, 5.7. That's that, right? Yeah, 5.7 times 10 to what? 6, 7, 8. Positive 8. Right there. Decimal to from here to there to the right. It's 8, I think, right? Yeah. Okay. Is that okay? Now,
Yeah.
I know this is like not a big deal, but I will make up new problems for you to be ready for it. You'll see. You're gonna do it right away. I already have my other students. I'll show you my other students' work. Then how about that? But okay, this one. Now, you just want to point out in other class, in other textbooks, in other math class, you may have this instruction written differently. How? Write it as a standard notation, not regular notation. So you can see the word standard notation. It's the same thing. So just write a regular number. But they normally will say standard form or standard notation. So this one, I think your teacher actually kind of type up the instructions. I can kind of tell. So and maybe your teacher got the instruction. I mean the problems from somewhere. Extraction maybe made up. It's no problem. You can make them up. I know how it has this on the bottom here. I take that
Yeah.
back. This is now it's yeah. But whoever wrote this didn't think this through way back. I think this is old now. I'm looking at this. This seems to be an old
Yeah.
yeah. But it's okay. Yeah, today they use the phrase regular. I'm sorry, standard form or standard notation. Okay, so I see. All right. I think you're okay. Look, it's negative. You move it to the left. See, now it stopped making sense. You see what I'm saying, dude? Just think about what I'm saying. Everything is the way I phrase it is perfect. The way I phrase it to conform to the sign of the exponent. Think about it, okay? Now you're moving it to the left. Why is it to the, where's the right thing opposite? Where is that coming from? And that's why I'm saying it right. So I have a feeling you teaching me, I'm talking about this side here. Then it's not making no sense over on this side. That's why. Okay, now we go to the left 6 times. That's why it's negative, dude. Like on a number line. So 6 times. So let's see how we do this. 9, 4, 6. Move it 6 times over. 1, 2, 3, 4, 5, 6. And of course you put the 0 as placeholder. There's your final answer. Now you can put the 0 in front here also. I would recommend you do that. Yeah, in science, you want to write that so you don't get confused. Okay, now this is +3. That's why you're going to the damn right, dude. Right? You see? That's what I'm saying. This is the right way to think. Again, yeah, your teacher may say opposite over here. Then it makes no sense when we're doing the standard notation here. So anyway, I'm sorry. The negative here, you're gonna move 1, 2, 3, but you have a 5 there as part of it. So there's your final answer, 2,500. Same thing here, -2, move it to the left 2 places. So it'll be point. I put a 0 placeholder here. I think you're good here. Yep, like that. 1, 2, yeah. And same thing here. You move it 5 to the right. If you don't see a decimal, it's right behind it, right there. So move it 5 over. 1, 2, 3, 4, 5. There it is. 40,000. What is it? 40,000? 400,000. 1, 2, yeah, 400,000. You put a comma here if you want, like to show. And this one, 4 to the right. It's +4. Move 4 to the right. Anyway, 7, 2, 5, 0, 0. 8 to the left. 8 places to the left. It's negative. 1, 2, like that. Okay, well, copy all the digits. 2, 4, 5, 6. Then move 8 places to the left. 1, 2, 3, 4, 5, 6, 7, 8. Put a decimal there. Add a placeholder in the front, and put all the zeros in between there. There. Just be careful on this one if you be neat, because this is like exaggerated number, huge. But the thing is that in science, yeah, it makes sense. The small numbers looks like this, but they don't write it. Oh yeah, if you ever wonder, before I move on here, if you ever wonder why do you write this stuff? Why do you write this stuff? Because in science, when something is really small, you don't write it like that. It will take like the whole row of a paper, right? There it is. If
Yeah.
you ever wonder, so this is the reason. If your teacher didn't explain it, well, you learn this in chemistry and physics. But yeah, they write like the biggest number, like the stars, like number of stars, trillions of stars and whatever, trillions of galaxies. They write in scientific notation. Get it? Like this big number and put a star, the word star right behind it, stars right behind it. So if they print out a scientific textbooks or documentation or research things, they put everything in scientific notation for big and small numbers. atom, things like really, really small, when you talk about chemistry. Yeah, that's how they do it. Okay, anyway, negative, if we go to the left from right here, the back of the 6. I think you're already probably done by now while I'm talking. Put a 0 here. And then 7 on the other way, right? 7 places. So 1, 2, 3, 4, 5, 6, 7. There it is to the right because it's positive. Makes sense now. And negative, we're going to the left where it started. All that. So we'll keep 5, 0 here. 4, like that. Add 0. And a placeholder too in the front. Let's get sloppy there. Okay, and then, yeah, so it's 800 here. Just move 2 places over. There it is. Now, I wanna kind of give you a preview of the things you're going to be doing with these stuff. Are you ready? Let me go to my other students' work then. Now, you'll be doing even way more than this because you're doing accelerated, like kind of honors, but the students that I have, it's not doing that. But have a look though. What you're going to have to deal with. Look at this one. Look at this. Here it is. This is one of them. Number 28. This is my other students' work. Oh, wait, you're done with that already, right? That's your homework, right? Your assignment.
Yeah.
Okay, look at this one. How do you do this, right? You're going to be doing this and dividing and then more, a lot more. You're going to have more than just this. So look at 28. To do this, you multiply the number part to the front number, the two front numbers, 3 and 15. So it'd be 45 right there. And do you remember like the property? Oh, you still have to do the X thing, to keep it in scientific, well, at least close to it at first. And then it will be, then you have to make a scientific notation at the end for sure. But since you're doing 10 and 10, the same base, you add the exponents. You remember that? Now you're applying the concept you were working on, the exponent property, the property of the exponents. So it'll be times 10 to the 10th power. You agree so far? Like that? Okay,
Yeah.
now this is something you haven't been assigned to do yet, or at least taught to do it. How do you think you can make this into a scientific notation? There's 2 ways of doing it: the fast way and the explanation, like a very very what do you call it, step by step, show all the work way. I don't know what word to describe that. The long way. Okay, now do you know how to do this? Like right now, it's not yet in scientific notation because you remember you're supposed to have it looking like this, dot, 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 whatever times 10 to some power. So this is not scientific notation. How do you think you do it? Let me see if you. I don't think you have been shown how to do this yet, but what do you think? Exactly written this way first. Now later on, they'll give you a bunch of these, and then you have to fix it into a scientific notation with the 10 part already given it to you. So what do you think? Not sure? You want to
No.
guess? Want to guess?
Yeah.
So okay, look, I'll let you try mentally. Okay, fix this one into a scientific notation, ignoring this. So what is that? Say it out loud for me. What is 445 in scientific notation? 4.5 times what?
4.5 times like
10 to what
10
power?
to the fifth power.
To first power, right? Okay,
Yeah.
so imagine that right here. Now add and then multiply that 10 to that. What is that going to turn into? 10 to the first power times that 10 to the 10th power. What is that going to turn into?
Uh, 10 to the 10th power.
Okay, right now it's 10, right? The one you got
Mhm.
here was 4.5 times 10 to the first power, right? But
Yeah.
then imagine 10 to the first power times this one in the back. What is that in the end? 10 to the first power times 10 to the 10th power. What is that?
Is it 10 to the 11th power?
Yes, final answer. But here's all the work. Now, there's a shortcut I'm going to show you right now. This is actually the long way. Your teacher will teach you this in the beginning. This is the beginning way. Oops. I actually, when I hold it on a piece of, on like other space, it will turn into that color. Like it turn into black by holding it. But anyway, 10 to the first power times 10 to the 10th power. This is what you said. So I brought this 10 to, don't forget, this is this right here. The 45 is right there. If I continue with this math, it'll be 4.5. a second here, sorry. Times 10 to the 11, oops. Times 10 to the 11th power. There it is, final answer. See that? Yeah, but this is the show of all the work. Like you break down the number that is not scientific notation, and then continue on with that and multiply using the property of exponent, the same base at the exponent. And here it is. So that's the answer. So here it is. See that? But there's a shortcut. Look at the answer, same answer, but there's a shortcut. Let me explain. My other student who did this already know. So here's a shortcut. But in the beginning, you may have to do all of this work. I don't think you need to. I think maybe your teacher will explain it, but then you can do whatever you want. But here's whatever you want. Here it is. Take a look. So what you do is this. You multiply the 3 and the 15. You get your 45. Okay? Now, the 45, if you look at 45, just 45, the decimal is right behind the 5, right here. If you move it to the left to make a scientific notation out of it, to make it look like this, right? It's okay? You will, if you move to the left, you will add. This time, it's where you do the opposite. Now, this is not the same thing as what we were talking about earlier. That's when you actually, that one is actually about you're making a scientific notation. This one is about multiplying. So this time, it's the way I'm talking, it's all good. It's all good here. If you're moving it to the left, oh, don't forget, you have to multiply the original here. Sorry. Okay. So this is now, a new kind of thing. If you're now making this into a scientific notation, right? The quickest way is that if you're moving this, don't forget, you have a 10, something to the 10 power. The work that you were doing earlier has none of that. That's why it's not the same. Okay. So you have 10 already part of the problem. So the quick way is the way I'm about to talk. I'm about to tell you right now. So if you have this as the problem that you have to fix into scientific notation, all you do is that if you actually move the decimal to the left, you will add as many as you want, like one left. You're gonna do the opposite by adding one to the exponent. If you move to the right, you subtract however many you move over. That's it. You see how that works? There it is. And then you can prove it. If you don't remember, go ahead and do it the long way. It'll give you the same answer. That's all. There it is. So there it is. Now let me see other problems that my other students are doing, so you can see what is expected of you. But you're gonna do a lot more because he's not in accelerated course. Or here's another one. See right here. Look at that, the multiplication. Now I don't remember. I think he has done the division one already. I think he has. But let's do this one quickly. Okay, watch number 19. The quick way. It'll be 12 times 10. And this one here, what is that? 9, right? So if you combine them, so far, 9.
Yeah.
So it's 9 here. Now, if you were to do the long way, you'll get the answer for sure. But let's do the fast way. The fast way is that it's 1.2. Since I move it over here, you will add 1 to there. Okay? Yes, that's the fast way. So you will be doing this for sure next, like right away. Oh, I'm sorry, take that back. The next may be something, you're not going to do this yet. Sorry. The next thing that you're going to be doing will be a number that it's not scientific notation, but it looks like scientific notation. Like it'll be like a bunch of weird number in the front, like 4873.1 times 10 to 8 power. Fix that. That's the problem you're going to be doing next. Fix that. Well, let's do it right now. It's okay. Yeah, you're gonna fix this one. How do you fix it? You'll be writing 4.8731. Since you move it this way to the left from the original, you will add. That's meaning you moved over 1, 2, 3. So you add. It'll be 3 to that. Will be 11. Okay. There it is. You can always prove that. Now, if the problem were written like this, take a look. And you have to times 10 to the 9th power. I'm making this up. How will you fix that? Okay, how you do that? You're gonna move it back to where you to the right, where you want it to be, right? You're gonna go over this way, so it'll be 8.43 times 10. How many places? 1, 2, 3. You're gonna subtract 3 from there. It'll be 6. Opposite. Is that okay? You go to the right, you do opposite. There it is. So that will be the next thing you do. They'll give you the problem that looks like this. That is not yet scientific notation, but you have to fix it. Then the next day after that one, you'll be doing multiplication and then division. Yeah. So yeah, I just want to give you heads up on what you're gonna do. So same thing here. What is that? Quick, let me do this one. 3.6 times 10 to the second power. Oh, you're done because it's already in scientific notation. Is that okay?
Yeah.
There it is.
Yeah.
Yeah, sometimes it's done, it's done. So this is his stuff. But let me see. Let me backtrack a little more. If he has some division ones already, I don't remember. So let me see this one here. We'll call it a little early, but let me look. He doesn't have scientific notation in this one, but they always come back around. They review a lot of things. This what's so great about this book is that they review over and over the same type of problems, but vary a little bit day by day. It's such a I like this book a lot. By the way, it's quite a bit. Let's see this one here. Yep. So every so often they'll go away, get off that topic, and then move on to something else.
Yeah.
But anyway, one last one. Let me look at one last one at least from his work. This one here. Yep, no scientific notation. But he started like way back, and then he came back around, and then it will go away again to accommodate new practice concept. So anyway, okay, now let me let me let me show you the long division one. I mean division problem, but I can just Google it quickly so you can see what it's like. Scientific notation, scientific notation worksheet. Let me see. I'll just look at the images. There'll be a bunch. But this, if I say that, it means that I don't do any operation. But here it is. They do sometimes. They will show you the operation that you have to do between them. So here, oh, look at this. These are the most comprehensive one. Here we go. Have a look. Let's just have an idea what you're going to be doing next. So you already saw number like the number 3 to number 6. Same thing that you saw earlier. It's a multiplication because you have parentheses between them. The first and the first scientific notation. Well, looks there are. Oh yeah, all of them are scientific notation.
Yeah.
You're multiplying scientific notation to another scientific notation, and then you have to fix that in scientific notation if it's not already in the end. Get it? Like you're gonna fix that. So number 3 to number 6. Now number 7 to number 12, you'll be doing it. Let me show you. Let me screen capture that. And then the power one, and you're wondering what it's like. So anyway, you get to preview what you're going to be doing. So have a look just quickly. So we have a little time here. So let me bring that in. All right, take a look. So what you're going to do with 7? Oh, is that good? Yeah, let me okay before I even write anything. Okay, good. All right, number 7. So you may be allowed to use calculator here. So because you waste a lot of time doing long division. I have a feeling you will. Hey, so can I ask up to this point, have you ever been allowed to use a calculator for anything?
I don't think so, but I think like a while ago, I think we used it like once or twice.
Okay, so if not, your teacher will give you a problem that is doable. Okay, like because I may be wrong because you're doing accelerated. That means you may have to do it by hand. But but I'm going to use a calculator. Okay, but okay, have a look. So you do your long division or whatever you need to do to divide these two. The 10 we do separate because the property you'll be doing it separate. Okay, so here let's do a 7.1 divided by 8.2. Have a look. So it's going to be this. Oh, okay, that's interesting. See, it seems to me number 7 is completely made up. So if they didn't, then it will be terminated. But this looks like it's repeated, right? I guess we can do it. Now it's a repeated what? Let me see. 658. Wait, is it repeated? Help me out here. What
I
does it
don't,
repeat?
I don't think it repeats.
It doesn't repeat, right? Okay, then I'm
No.
gonna write the whole damn thing. Sorry, dude. Write the whole damn thing. What? Wait, 8658. Now, wait. I have to explain. This calculator has this thing called a float. It stops at certain decimal because it does not want to fill up the whole row. So it stopped on its own. It will round it on its own. But if you want to see the actual, you have to go through something else. So let me do this one. Jeez, sorry. What was that again? 7.1 divided by 8 point something, 8.2. Let me see. 8.2. Look, you see, it continues on. Let me see if it's going to terminate. This one will tell you. Nope, it does not terminate. It means it repeats. There is a repeating pattern. Here it is. You see the
Yeah.
bar over the 6. The bar is over the 6 and end at 3. The bar over the 6, end at 3. You okay? Right down here.
Yeah.
6 end at 3. Let me see. 6 end at 3. So 6 end at 3. Let me 8, 5, 3. Okay, 5, 3. So here it is. You can write it like this. So 6. Okay, no problem. You can do this. Then you're going to do 8.6. Wait. Not yet, not yet. This right now is that, and then 10 to the 5th power. You okay so far? Okay, now
Yeah.
we fix this. It's going to be 8.65853, but the bar will be right here still. And then you can do 10 times. Remember, the original is here. You move this way, you will subtract it by however many. I can't even say that, dude. However many you moved over. So I move over the original here and move over to the right. It'll be subtracting 1 from it. There it is. Final answer. Is that okay? Yeah. There it is. I just want to show you that. So that's what you do. Now look at the one that with exponents. So I'm going to jump to this one, number 13. And I think you're done with all the scientific notation. After you do the 13 form, like the ratio to another power, have a look. This is awkward, by the way. So 8.9 to the 4th power, you have to do this. Then 10 to the 20th power. Tell me you remember the math that you were doing before, right? You're going to apply to it. Yeah, you're going to apply to the scientific notation one. There it is. But then let me punch in the calculator. The 4th power. Look at that. So you can tell these are made up, dude. 6274, 2241, I think. Yeah, this one looks like it terminates for sure. Yeah, okay, good. Times 10 to the 20th power. So you got to fix that and we're good. Let's do it one more quick way, okay? So it'll be 6.2742241. Since I moved this way 3 places to the right, I move it to the left. I have to add be 23rd power. Done. Okay? There you go. Done. So I just want to give you a preview of what you're going to do. That's it. Same thing with the negative and all that. You have to deal with it. Oh, dude, last one. Because it's a negative exponent, what happens here? Take a look. So you can multiply, become positive 30 here. But how do you write this stuff right here, right? Let me see what it looks like in the calculator. I hope you don't get this one. Raised to negative 6. Look at that. So this one, you can tell it. This one is entirely made up. Now, if you wonder what does this mean, what is this calculator? Let me show you what this means. You're likely going to have to learn to use a calculator, like scientific calculator. This means this is 2.4 something. I'm not gonna write the whole thing. 2.441 times. Now, what is this e thing, right? This e thing is the same thing. It means the same thing as 10 to the negative 4 power. That's what this means in the calculator. So you'll see this in your scientific calculator that you're probably gonna have to use. Like your brother has this a white with the yellow orange key things that your school make you use. It's profit,
Yeah.
dude. You have to see. It seems like he bought it. He has to buy it. So that's kind of bad. I don't agree with that. You should be allowed to use like your cell phone, your app. You know what I mean?
Yeah.
Or your own calculator, scientific calculator. You could buy it used easy. So this is it. This is what that means. So that means you have to fix it. So let's pretend that you copy all the digits. So here it is. So it's going to turn to 4, 1. I'm not going to copy all the decimal here. 10 to negative 4, but then times 10 to the 20th power. See that? So you have to do the separate math here. So let me finish this and then we'll call it. So here it is. So continue. So don't forget 4 to negative 6 turns into all of this here. Okay. Now, well, what does that mean? How does that work? Well, if you do your math, remember it's this. It's 4 to the 6th power. It's the same thing as 1 divided by a huge, what is that number? Whatever that big number is. Get it? That's why it turned into this a small decimal number. You know what I'm saying, right? Yeah. Yeah. Anything, a fraction divided, something in the numerator divided by a very, very big number, it's a very, very small number. The small number is like decimal. This is scientific notation. It's moving like 4 places over in this way. So it's really a decimal number. So anyway, so far we got this. Continue. Almost done here. This is already in scientific notation. I'm glad. So we just need to fix the last part and we're done. So it's going to be 16. Done. Final answer. Okay, you see that? There it is. We combine the
Yeah.
last two. Okay, anyway, that's it. I want to show you that. All right, dude. We'll call it. I know that you yeah, you're probably exhausted. But you just came from like the cross country thing, like gathering
Yeah, I
group.
just really
Yeah,
had to take a shower.
I see. That's why. All right. Tell mom thank you. I'll see you next week. Okay. Yeah. Take some.
Yeah.
Get some rest and